And we're here today to talk about logarithms.
Or logs, which you've heard in the past. And what are logs? They're not like these logs in this picture here rolling along here.
Oh, silly
Is that
gooses.
a casket? What is it pulling on there? I don't know. Silly goose.
These are not the logs.
Those are not the logs. We're going to talk about math logs, okay?
So logarithms.
Logarithms.
Okay, so let's just stop and before we even begin to discuss what a logarithm is, maybe we could look at the equation y equals 2 to the x.
Yep.
So in this equation, y equals 2 to the x, well, let's look at what that would look like on a graph. We'll pick some points, maybe -1, -2, 0, 1, and 2. We'll plot these points on our graph. So if I had -1, we have 2 to the negative 1.
They know what that means now, right?
That's just
1/2.
So I'll go over here, actually maybe I'll make this one -1. And this down here, -1. So if I have 1 and then 1/2, that would be right here.
Yep.
-1, 1/2, sorry.
-2 then is 2 to the -2, giving us 1/4.
1/4. So if I have -2, we're getting closer right here. What do you suppose is going to happen as we continue?
I think it's going to go closer and closer to that line, but it's never going to touch, right?
And that, and that'll probably be our horizontal asymptote. So what about if we had 2 to the 0? We all know that rule. That's just 1. And 2 to the first, being 2. There's 1, there's 2. Well, 1, there's 2 this way. And 2 squared being 4. So
this is what's called a classic exponential function. When we look at it, it wasn't one of our parent functions, but this is actually a parent function.
It's a new parent function.
New parent function. And it looks like that.
So there's our exponential function. So that means by looking at the graph, we can solve for many things. First off, if I said, well, I want to know what my value for x would be if y equals 4. Well, I can look at the graph and say, okay, here's y, 1, 2, 3, 4. All right, it's this point, which is 2. So I could say, well, that's x equals 2, but we know that one by heart.
Right? So, but what would you do if you had y equals 3?
So now I have this equation 3 equals 2 to the x. So how would I find the value? Well, I just go over here to my graph, 1, 2, 3, look over and, I don't know exactly what that is.
So in order to get an exact value is what we're going to look at in this unit is solving these kind of exponential equations using logarithms. So we solve this with and without our calculator. Sometimes you can do it without your calculator. Sometimes you absolutely need your calculator to solve an exponential equation.
So a couple other examples is maybe we wanted to know 11 is 2 to what power? Or we want to know 10 is 2 to what power? Logarithms will help us solve for all of these exponents.
Okay, so let's learn the mechanics of how we do it without our calculator, okay? Or without a graph even.
All right, so let's just think about what log actually means. And we just want to think being exponents. So that means if we have log base A, that's read as log base A of x, that means the exponent to which A must be raised to give you x. So that means if we have log base A of x, that actually means the answer, okay, so let's see. We could say A to what power, because it's the exponent.
Yeah, the answer is the exponent. Do I need to raise A to give me x?
So what power do I need to raise A to get x? And that's what logarithms do. So if we think about this, Mrs. Borb's got a fancy name for this, of course.
This is like, just like we had the diamond method, this method is called the ear method, okay? And what you always do is you start with the base, which is A in this case. It comes around and you raise it to that power, and that's equal to x. So we're always going to set up our equations the same way, just like that, using the ear method. and solve then for our question mark. Okay, so let's look at a couple examples. We can start here with the log 3 base 3 9, and if you write it out, you have log 3 base 3 of 9 is equal to, and so we would want to figure that out, right? We'd start with, so we're looking for the exponent to which 3 must be raised to give us 9. So we start with the base of 3, we raise it to a power, we don't know what that is, that's going to be our answer, and that's going to be equal to 9. So everybody knows that 3, what is 9? 3 squared is 9. So our answer is 2.
So we could write log base 3 of 9 to just be
2.
2.
So the entire thing, log 3 base 9, is 2. That's your answer. 2 is your answer. Or you can replace log base 3 9 with 2.
All right, the other question we had here is this one, log base 3 of 81. So let's try this again. To find our solution, we'll do the ear method.
3 raised to what power gives us 81. Do we know what that is off our top of our heads? 3 times 3 is 9. 9 times 9 is 81.
I can change it to the same
yes,
base.
You can.
So I know that 81 is the same thing as 9 times 9, like you just said, which is 3 times 3 and 3 times 3. So that's 3 to the 4th. So therefore, the question mark is going to equal
4. So answer is log base 3 of 81 is 4. Good, let's look at a couple more examples. And we're going to use the ear method again. We're going to start with the base of 9. First, we're going to put it in a question mark. Good. Then we're going to start with the base of 9 raised to what power is going to give us 1. And we know what that is. Question mark is equal to 0.
So we could rewrite this whole equation to be log base 9 of 1 equals 0.
Did you know that was a way to write 0?
Interesting.
Interesting. Fascinant. Okay.
So log base 64 of 4 is question mark. 64 to the question mark
is equal to 4.
4.
Hard one. Do we want to do bases? Let's try it with the same base, right? We just practiced that over the last couple of days.
All right, so we know 64 is the same thing as 8 times 8. Okay, we know that's the same thing as 4 times 2 and 4 times 2, which is the same thing as 2 times 2 times 2 and 2 times 2 times 2. So 64 can be written as 2 to the power of
6 or 4 to the power of 3, right?
Yeah. Okay, and then 4 can be written as
2 squared.
2 squared. So we'll do it with 4 after this, but let's just stick with this one for right now. 4 would have been easier, I guess, huh? So we could say 64 to the question mark
is 2 to the 5th question mark, right?
Is 2 to the
2 to the 6th, sorry.
Question mark, which equals 2 to the 6th. From there, we know that question mark.
2 squared, right? Wasn't it equal to 4 over here?
Oh, yeah, I'm sorry. Yep. Good catch, Mrs. Moore.
Good thing we would have had to pay.
I know. This is the same thing as, what am I writing for? Yeah. 2 squared here. So we have 6 question mark equals
2.
2.
Question mark is equal to?
We all know that.
Divide by 6, right? Divide by 6, and we get 1/3.
So that means we could write log base 64 of 4 to be 1/3.
Okay, I think that's enough for 1, huh?